Okay, so for 61, I know that if one of the zeros is 9i, that means another zero needs to be negative 9i. And they're telling us to write it in factored form. So that's x minus 3. And then to get a 9i or negative 9i, we've had to square root something. So that's x squared plus, and the square root of what number is 9? That's 81. Then for 62, it's going to be similar, x minus 8, but we actually have two different I values. So to get 7i and negative 7i, that is x squared plus 49 as a factor. And to get negative 5i and positive 5i, that's x squared plus 25. Because if you think about working backwards, to get x equals, let's say, 7i, that means we would have had a square rooted negative 49. But to then go backwards from there, that means the factors x squared plus 49 equals 0. Okay, so for 63, what we can do is synthetic division to see if we get a remainder of 0 for each factor. So since the factor is x minus 2, I'm going to divide out a 2. Bring down the first one, multiply and add, multiply and add, multiply and add. Because we get a remainder of 0, a is a factor. So do the same thing for negative 6, to check if x plus 6 is a factor. Multiply and add, multiply and add, multiply. That's not going to be 0, so b is not a factor. For c, x minus 5, so we divide by, or we put 5 in the corner. Multiply and add, multiply and add. That's definitely not going to be 0. Then to do d, I'll put negative 2 in the corner. That's not 0. For e, we put negative 3. And we get a remainder of 0, so that means e is a factor. We've got one more to try. For f, negative 5 goes in the corner. And f is also a factor. Okay, so for 64, because it says divide by x minus 5, we can use synthetic division. I'm going to put 5 in the corner, and then our coefficients, I don't have to hold any places with any zeros. Wow, that's really nice. We get a remainder of 0. Because the degree was 3 to start, our answer, these are the coefficients of a polynomial of 1 degree less. 65 I did in the calculator video. Now for 66 is a possible rational 0. So what I'm going to do is list out my possibles. It's going to be the factors of 15 over the factors of 4. So let's see. Is 5, for this we get 5 over 1. So A is a possible, oh, you have to write yes or no. A is a yes. Negative 1/4. Here's negative, all of these are plus or minus, so 1/4. B is a yes. For 3 over 2, we have that. That's a yes. 4 is a no, because there is no 4 option in my numerator. And then 1/3, that's also a no, because there is no 3 there's no 3 option in my denominator. Okay, so 67 just says list the possible rational roots. Can do that down here. So I like to set myself up to begin with the factors of the constant divided by the factors of the leading coefficient. And now we have to list them all out. So I'm going to do every possibility. 1 over 1, 2 over 1, 4 over 1, 1 over 5, 2 over 5, and 4 over 5. But they all have to be plus or minus. And there's all of our possible rational zeros for number 67. Okay, so for 68, a 4th degree polynomial could have how many imaginary roots? So we're going to set up real and imaginary. If there's 0 real, that means there's 4 imaginary. Imaginaries can only come in pairs, so if there's 2 imaginary, there's 2 real, and 0 imaginary, there's 4 real. So our answers are 4, 2, or 0. Now 69, I did in the calculator video for part B. So part A, how many zeros? It has 4 because that's the degree. Okay, so for 72, it's a no calculator question, but they gave us a graph. So to use the graph to solve the inequality, we want all the points less than 0. So that's everywhere this graph is below the y-axis. So for what x values does that happen? That's every x less than -3 and every x between a high value of 5 and a low value of 1. So for 73, they give us the zeros. So what I can do is to write it in factored form. It's going to be x minus -6, x minus -1, and x minus 8. Now I'm going to use those zeros to get a sketch of the graph to figure out what's going to be above and below the x-axis so I can solve the inequality. Because it's an odd degree positive leading coefficient, I know the end behaviors are going to point in these directions. So the only way to sketch this end behavior and go through these 3 zeros is to go up and down and back up. So the parts of this that are less than or equal to 0 is here and here. So the answer to part B is every x less than or equal to -6 and every x between -1 and 8. Okay, we're going to repeat that for 74. Factored form, they give us the zeros. I don't even need the y equals. So for factored form, that's going to be x minus -3, x minus 4, and x minus 7. So if I sketch a graph, and it's again an odd degree positive leading coefficient, so that's this end behavior. And we want everything greater than or equal to 0, so that's here and here. So that's every x greater than or equal to 7, and every x in between -3 and 4. So that's our answer to part B.